and the open source part. The goal of this session is, my goal is to convey how I have been able to grow technically by building, sharing, and refining, and how far that has taken me. Now, I will start with Plotnine. Have any of you guys heard of Plotnine? Good. So I will start with that, what that is, so that because that sets the story for everything that all of us in there. Then everything follows from that. Now, if you follow this link, you'll be able to clone for people in Zoom. They can clone the info. You guys all you can just watch me show you what Plotnine can do, and then we will come out with this presentation. Click. Visualization library based on a concept called the framework practice. I am going to walk you through using Plotnine to create visualizations while you are, exploring data and analyzing data. I don't want you to stress so much about understanding the code. I will point out what matters and what you should look out for. Now, are all of you guys familiar with Python? Okay. So the first block is just the defaults, regular, regular. And I also have some maps of Uganda from 2014. We will be using those later on. So I import things from Plotnine, I find some useful libraries, and then I read the data. Now this data was the census 2024 census summary, which showed the statistics for the cities, the population of the cities during the day, the regular residents and the visitors. So it was posted on the UBOS website, and this is a copy of it. This came out before. This was the first summary that came out before the result. Then I get to manipulate that data. Don't worry about it. Just look at, just get a sense of what this looks like. So we have, this is the main data. We have the city, then the type of visitors, the type, either residents or visitors, and the number. And then I just change the format of that one because when I'm plotting, some formats are more advantageous for different types of plots. Then I also get my map data and put my map and put my cities in the maps so that they can so that I can draw them onto the maps. So I have the cities, the locations, the geometry of the city, the population, and the distribution. So now let's get to where Plotnine starts. Oh, sorry, I haven't been running this. So we'll run that. So the first one. Okay. This is probably the most basic plot. I get the city, on the x-axis, I could have said x equals, and I could have said y equals, and y is the number of it's the count of it. And I create a scatter plot. So I say the data, x-axis, y-axis, and this is what I get. So what we see here is that we have two data points for each city. So, and we should expect that because each city has the visitors and then the residents. So we can decide like, okay, let's differentiate them. And we get, I add this, which is the color, and say, oh, I'll set the color to be the time. And it gives us a legend, which tells us, oh, we have the residents in some kind of orange color, and a light bluish color for the visitors. So clearly, a scatter plot or points is not the right type of plot for this. Maybe we should do a histogram because everything goes up. So that's like the sign to say like maybe let's have for scatter plot, and what we have for histogram is, so I'll run that again, is I just change this column set. I just say I want columns instead of points, and that gives me two columns. But now columns have this extra thing for rectangles. So they have an outline and then they have an inside. And when I can address the inside and then the outside. The inside is, you fill the inside with the color, and then the outside is just the color. So this one works, the color, same color works for points, but it does not work for the insides. So I just change that and say fill, and that says, oh, no, don't put the, fill the interiors with the rectangles. And then this is what we get, the histogram. And let's change the color. Let's have side by side. The difference is the position dodge. What dodge says is essentially like, if you are going to collide with someone, don't collide with them. Just step aside so that you don't touch each other. So that is what we have over there. So they were colliding, touching each other. So dodge says, hey, put them side by side. So we have the visitors and the residents to the opposite side, like adjacent to each other. So maybe now let's change the color. And whenever you're visualizing anything, you're dealing with scales. The reason it isn't apparent when you're dealing with a position and with the x and y axis is because they are so hidden to us, but you are getting data from outside, say maybe very long distances, and then you're scaling it to fit on a small line or a small coordinate system. So you're already dealing with scales. And that extends to other things. I'm getting some data, and I'm mapping it to a color. That is also, it is in the same category of a scale. So for the X and Y, the position scales, those tend to get hidden, but when we are working with the system, it brings them out. So the color, as in there are default scales, and here I change the color of the scale. So when I comment this out, I get something like that. That is what we had before. When I run it, it works on a color scale called HCL, whereby you can the colors of, think of the colors of the rainbow, change from, you have go 360 degrees. So you can start at 0, there is a color there, and then all the way, you can expect from 360 to be the same thing. And then in the middle there, you get you can choose choose different settings and get different colors. On the other hand, it's most people are used to like hex colors. But this one allows you to adjust for things like lightness. So HCL lightness, I can say the lightness goes up to the lightness, yeah, changing. So the color stays the same, but a different attribute changes. So there are different color systems, and this is one of them. And you can there are other color scales that we could have chosen, but I'll just give you a test of it. So let's go on. And now here, this is the plot that here look at it and like, okay, it has all the information we need, and I can say I can go all out and customize it, and this is what this code does. It customizes it like that. Same information. I had a title, I had a subtitle. I changed the labels for the breaks along the y-axis, the x-axis, and give it a caption. I changed the position of the legend, and all that is happening in this code. Now this may look like a lot, but all of it is composable. It is bit by bit by bit. For example, I can undo all of this bit, the theme, because it changes the general output. So I can add a playful theme that just undoes. This is the original that we've been working with in the default. So if I run that, so yeah, that is the default. Or I could get a playful one. So, or I could put that playful one above here, and then just modify small bits of it. So we have the same plot as before, but it's, it doesn't look as serious. And definitely I can go back to, I can say, this is my best, and these are the attributes that can change. This one is a complete, it specifies everything. But when I want to modify just some of the elements, I add in and then modify as I wish. So that is it. Now let us map the cities, that information to let's create a map. So again, looking at the map data, we have the names of the cities. So I think it's I think this is all 10 of them. Then we have the longitude and latitude, and then they have the geometry, some geometries is yeah, points, and then the population, and then the ratio of visitors to the residents. So again, we create a map. So this is the default. So if I just go down, this is like the simplest plot we could ever create. So it just says, hey, digital. So it doesn't add anything. Then I add a map. So this is the map. I imported it I take out the interior. So I say, hey, fill, don't fill it with anything. And then I give the border some like increase the size of the border, and I give it a color like that. So we are progressing, changing, and then I have some water bodies. Earlier at the top, I got the large water bodies, so the big lakes and big rivers. If I hadn't done that, I would have gotten like all the water bodies that were mapped and put in and saved to the data set. Maybe I can do that and show you what it looks like afterwards. Then I change the watercolor to make it like, yeah, make it look pleasant. Say I add the watercolor. I say, hey, come here. For the water bodies, change the field. So now it looks good, it looks better. So I have to remember to keep running, then scroll down. And then I want to add the cities. So the cities are points. So I say, hey, I use the map to add the water bodies. I use the map to add the outline, and then I use points to add the cities. So these are the cities. Now, the size of each of these dots corresponds to the size of the population. And then the color corresponds to the ratio of visitors to the residents. So all of that is specified here, and we get the legend like cheap, like that. And we continue. Let us add the names of the cities. So this, from the previous cell to the next, this is the only new bit. We say, hey, at the longitude and latitude, make the label the name. Because the name, if we look at our data set again, which is cities, the name, we have the name column gives us, has the names of the students. So it puts the name of top of the dot. So we don't like, so we have something basic, and now let's go all out and make it. Now this is, this just does like the prettying things, bit by bit by bit. And with that, it gets like this. So is in terms of like the data, it is the same as this basic thing that we have developed. But here we have gone through and customized, say, the background, we have done the titles, the subtitles, we have increased, I remember that scale thing that I talked about. We have increased the range for the sizes of the population. So, and we have here, so the size of this, which is the radius, of the points corresponds to the number of residents. So very fast, you get a visualization that you can tweak to your heart's content, just like that. And for people on the PyData Kampala WhatsApp group, you may remember that I posted this sometime ago last year. This very exact thing. So that is why I was like, okay, I'll bring back some, because I said that I will publish, I will publish the code, but I didn't get back to it. But yes, this is how I created it. This looks like a lot of code, but remember, the basic thing is the code that falls onto the panel. And then these ones are you address them bit by bit, and they are composable. So you're not struggling to think about so many things. You can say, okay, I want to change this small aspect, and then you change it. So in a nutshell, that is Plotnine. Now let's continue. Let's go back. Any small questions? Okay. Now let's go to the meat of the talk. How did that come to be? Now, for me, it started with elections in 2011. I was after the elections, we had the results published in the newspapers. We had by the media houses. Obviously, you get the analysis on TV. You get you had some NGOs put out things, and I looked at it and I was like, is this the best analysis we can do? analysis and how we do the breakdown. You aspire for more. But I looked at ours and I like, I want to know more, but I didn't have that. Luckily, the Electoral Commission publishes the results on their website. So I went there. So I was like, if I want to, analyze it in a way I want, if I want to get the analysis that I want, I have to do it myself. Because yeah, it's so I look for the results on the EC's website and get them. I struggle with them, and then I discover that okay, to do the analysis that I want, I have to choose a programming language that is meant for this type of analysis. So R programming language, I spent a week looking at R, I spent a week looking at Python, and I choose Python. And so I start running Python so that I can analyze the results. So then I start analyzing. When I start like, okay, I'm running Python, I'm installing the analysis stack, like pandas, matplotlib, numpy, and those things they were able to install. And I start. And then as I got the hang of it, I started saying, like, okay, now I want to draw things out, like, make graphics for what I am analyzing. And that's where the problem came, is that because I was doing this on the side, and I do something today, maybe 4 days later, I come back and I have forgotten, okay, what's that syntax remark? I was unable to get some fluent analysis code. So I looked at it and I'm like, is this the best plotting library that there is? Maybe there's something else that I need to do. I need to change. And with that, I looked around and then I went back to R and I discovered ggplot2. When I looked at that code, it was like the most elegant thing I had ever seen in terms of the way I showed you Plotnine works, because Plotnine is translation of ggplot2 to Python. But it wasn't there. When I looked at ggplot2 code, I was like, I want this in Python. I want to be able to use this type of visualization system in Python. But it wasn't there. I looked around, but I knew I was looking at something revolutionary because the idea was great and someone was going to do it in Python. All I had to do was wait. Someone capable was going to do it. So I waited. So that is I waited. While I was waiting, I read I read a layer program of graphics by Hassan Kibirige. Now, this is the PhD thesis on which ggplot2 is based. It is free online. It is a layer program of graphics. So it took what was a very theoretical concept called a program of graphics, and then made it practical and built a layer program of graphics. So when I read that, I was like, oh, okay, this is interesting. I want to read the book on which it was based, and then that book is it's called let's forget this. It's called A Grammar of Graphics by Leonard Wilkinson. It is the most expensive book I ever bought. It was it's an 800 page, but I was so motivated. Yes, I read that. Well, obviously I was waiting for someone to build a grammar of graphics visualization system in Python. Now, let's forget this. In that book, I was specifically looking for something. How do you translate? The reason I didn't stop at the PhD thesis, because it's very readable. That if you read the frame of graphics, because usually when you think of it's oh my god, this is but it is very, very, very readable. As it's like it's like you're reading a normal written book that is shown to you just the same way. But I couldn't translate between like, how do you get this system and translate it to the really original code? And there I was looking at, okay, how do you implement this system? And in there, I found that this is like that transformation of how your data comes in. It is a process. It is a process. It is a process, a pipeline process, and the transformations it undergoes up to the very end. Luckily, like this was like you finish chapter 1, and at the moment you start chapter 2, and it tells like, okay, this is what you have to implement to get a grammar of graphics. So, okay. So I read through it. It's a very hard book, but I had already bought into it because you're dealing with, in there you get exposed to these obviously concepts that you don't, you always take for granted, like scales, like coordinate systems, like guides, and smaller bits of concepts between, as in, and the connections between different coordinate systems. So it's like it's very dense, but if you have a target, it's like you go through it and appreciate the details. So I got from that, and then I waited 2 years, and I was like, okay, someone is going to implement this thing in Python. I waited, and then 2 years later, came up, and it was called Digital for Python. Now, Digital for Python is this. It was a package, just like Digital does, that says, okay, now here I brought it to Python. I was like, yes, someone has done it. Now I'm doing my Python things. I will use this from of graphics. But I was surprised. I was disappointed when I started using it because I will use an analogy. Imagine you want a very posh car, say a Mercedes. You have longed for Mercedes, maybe you've even driven one, and then someone says, okay, now I've gifted you a Mercedes. So you go, you drive, you step on the gas, and the thing is going there. This doesn't have the power of Mercedes. So maybe you know something about you go open the bonnet, you look at the engine, and it's a Vitesse. That was my experience. I had read the theory of like what a graphics is, the implementation, digital, and then when I looked at this code, I looked for that pipeline thing where it's implemented, and it wasn't there. So they were just getting this syntax and just wrapping plain matplotlib on it. But I was like, okay, we have gone through that. It is open source. I can contribute to it. And make it better. So I started. If you go to this repository, I made a bunch of contributions, a pull request. I started out. Now this is like really me starting with open source. Okay, the first ones, because now I have although I wasn't doing much Python programming, I was like, yes, I was like doing little by little. So I could read code and say like, okay, now you can do this better. So I start improving it like small bit by bit, and eventually the contributions I made got bigger and bigger, and then I hit a stop, whereby I had to tear out the whole engine of the what you call the whole engine of the library, and give it something new, and that is where we got. So I factored many things, all making contributions, they get accepted and whatnot. That is where I got to the big, what is like almost a rewrite. And that took me a long time.
So you did find any roadblocks while contributing, like if I know every person has to do it.
Yes, you get those, because when you start out, you have a sense. You pay attention to the conversations and the way things are done, and you make sure you get a sense of whether your contribution will be accepted. And first, you start by finding an issue and say, hey, this should be like this. You see, attraction. when they say, go ahead, they didn't go with Meetup. So, and I have so many issues in there whereby I may classify an issue and say, okay, this is wrong, this should be like this, this should be like that. And I got into some conversations with someone else who was interested in the library and started making contributions to it. But when it came to like the big thing, this big one where I was like, okay, I need to tear out the whole thing. I went bit by bit by bit, and this, I posted this on August 18th, 2014, and it took me a year later, like August 20th, this person here was the owner of this digital Python project. It was like, would it be possible to just fix what you have and merge in? I realize it's not done, but I am worried it will never be complete if we hold out for feature complete, same as digital Python. And to me, like, this attitude was unacceptable. Like, I'm going for something authentic. This person had already, put their British engine in a and they wanted me to like, okay, just brush up things and let's put this thing and like keep it up. Like, at this point, I realized that if the project was going to succeed, its best interests lie with me. In terms of, I understood what it had, I knew what it had to be. Okay. I was unwilling to compromise on the authenticity. And if I let this person keep, if I let my work get into my work be managed by this person, they haven't shown me that they care as deeply as I do. And that is when I decided that I am forming this project and I will see it out to completion as my own. So at that moment, that is when I realized that I have to make a library of my own. And that is when, in my head, Plotnine was born. Now, obviously, I took a little while to like, okay, getting used to the idea that I have to create a library, because before, the reason I wasn't the one I didn't create this thing in the first place because I didn't know of like any other person like this who had created the library. So there's some mental adjustment that I had to go through, but I knew right there and then that I had to go there. Now, luckily, I got some support, and like, see, there's this person here who's like, okay, he's like, I have checked on this TTP2 branch a couple of times, and before noticing this rewrite, it looks like RStudio, which is my username, would like to wait, finish making changes, and more power to him since the contribution looks really impressive. So this person is like saying, hey, okay, let this person and give it prominence, like, let him do your thing. Let him do his thing. So this person, not them. So, anyways, I go through it, and it wasn't until 2017, like April, when I put out the first release on Plotnine. So I abandoned so the owner of this repo did their own funky rewrite, repolished things a bit, and then they put it out, but it still wasn't a form of graphics. So closed mine, and then and that is when I created. That is how Plotnine came to be. The first release 0.0.01 came out. I think it was April 2017. From August 2024 from that pull request to April 2017, I was on the side doing this thing slowly by slowly, and yeah, that is how Plotnine came to be. Yeah. So let's take a break, a few minutes, and and we continue. So any questions?
Still maintain, right? Or
Yes, still continuing.
and you have contributed before?
I have, yes, they have computers, and we'll go through that. Yes,
When we contributing to the package, do you hide code? What do you have for just say that we contribute to
yes, you code. This is coding.
Yes.
Yes, visualizing. It gives you a composable way to visualize. That is what I started with. Like the first part was like taking them through what Plotnine code looks like. Then this part has been showing you how we got to that. And the next part is we'll see.
I'll go on the material and take that. What's yours?
Okay. Yeah, okay, let's continue. Now, while I was going through that journey between me wanting to look at election data, me wanting a better visualization library, I noticed something. When I started in 2011, I had never heard of the word data science. And it wasn't like, if you didn't even know to search for it. But within a year, everything had changed. Because I started, I was doing like data analysis. But within a year, like data science was everywhere. And I was like, what is going on? I was confused. I said, why don't you just call this thing data analysis? And what, like where does this data science come from? And at about the same time, I saw this painting by a Frenchman called Paul Gauguin. Now, this is a painting done at the time of the 19th century, so 1890s, about 1890s. And it happened at the time when the context here is very important to what I'm about to say. It happened at the time when people were like, the age of the world was being revised from in the 50 years before this painting, the age of the world had been revised from like, oh, the world is only like 10,000 years old. Then, no, it's 10,000. No, it's 50,000. No, it's like 100,000. No, it's a million. It's a million years old. No, it's like a billion years. Like, and it was confusion. And then when it comes to people, they're like, oh no, what of like this evidence with like apes and whatnot. So and when it comes to skeletons and like what of like these like giant lizards that we're digging up in the that we're finding in the fossil record. So that is the context in which this painting was made. It's by a Frenchman, and right in that corner, the top left corner, are questions, and those questions are translated are: where did we come from? What are we? And where are we going? Now, I related to that. I related to those core questions because I felt the same kind of confusion where I was like, okay, what is this data? What is this data science? And my takeaway was when I am confused, ask questions. And the questions I asked is like, why is data science necessary? Like this term that is coming up. And why now? Like in 2000, like about this, it was like 2012, 2013. Why now? Why before? And I was really into finding out exactly why, because when you have dialed in so much into a topic or into a into a rhythm, into something, and you find joy in it, and you you have questions that maybe other people may not think of as as important, but they are important to you, and actually it so turns out that I don't know as much as I thought I do, or maybe there's something missing, and you're trying to put a sense to it. So that is these questions for me. Those questions come from the inspiration from that thing. Now, so after that, so when I had those questions, I was like, what is data science anyways? The the quick explanations I found online at the time, they were not helpful. And I went through like, okay, if I am going to make sense of data science, I have to ask what is science? Now, when I ask to you people what is science, I know the phrase that goes each and every one of your minds. Do I need to say it? Science is the study of living things and now, in primary two, when we memorize that and we repeat it for the next 6 years until when we probably never make it. We don't really realize how ridiculous it is and how meaningless it is. But then after that, you don't confront it because it is never asked again. But think about it, it is a study. Like that means it is a study of anything. So this time, when I'm asking what is science, I looked at it and I'm like, yeah, when I was going through school, yes, but now okay, what is science now? Now I wasn't playing games. It's like I had to make sense of science. And then obviously also ask what is data, and by getting those two out, hopefully get a sense of why this data science thing came to me. And I went through the journey of finding out what is science. And that journey will to me say that okay, let me go through how did science come to be. And that I'll try to summarize what So, and that journey starts 2,600 years ago in Greece. So at that time, the civilization had, gotten to a certain level. So you had a class of people who were comfortable enough. They didn't have to work and have their hands, and they had time to sit down and think. And when they started sitting down and thinking, they're like, wow, okay, the way our ancestors have been described in the natural world has been very mystical. We should start describing the natural world in ways from the things we see and whatnot. So they started that. But soon, so that is the part of Greek philosophy. But it got very interesting. And by interesting, I don't, yes, I mean, yes, interesting, but confrontation. So they had very many disarguments because they did not have them. They were just starting with these things. You say this is what we see, but what is causing it? This person says, oh no, this is causing it. Another says, oh, that is causing it. So it is not enough to say that you're going to describe the world based on what you see, as in there's something more, but they didn't have a mechanism to resolve those, okay, how is causing and whatnot. So 200 years later, it's still within that same society. You had the back of logic. Now, logic is different because logic is you set your premises. You say, okay, Hassan is alive. No, everyone in that room is alive. Hassan is in that room. Alive. With logic, there are no disagreements. So they have their philosophy and interesting things where they could argue and then this, when 300 years later, they got logic and they're like, okay. Here, like everyone, like within the logic system, everyone agrees. Then years later, they get geometry. About 200 BC, philosophy, logic, geometry, that whole topic of Greece, goes away. Paul loses its power, gets passed on to that. Now, the Romans get this package. They don't do much with it, but they preserve it. And for 400 years, until the end of the Eastern Roman Empire, they are preserved still. They exploited it in the thing that they used it, the science, the math, and the geometry, to build things and whatnot, but they didn't really add enough to the whole. So they get this, and then when they are phasing out, you have rising empire, that picks that up, and they look at it like, oh wow! So they translate, and also they were at the stage where they had a class of people who didn't have to toil with their hands, who don't sit down and think and why not so they can stay. We have a neighboring empire like somewhere southwest, the Indian civilization. They borrow from them, and they add something like arithmetic, number zero. They do something with the philosophy and whatnot. So, and when they are phasing out in the 14th to 15th century, the Eastern Europe Roman Empire had collapsed so like all of Europe was had kind of formed itself, and then they picked up this package of math, logic, like philosophy. But this time it was different. So they too,
what you're talking about now, it has
yes, so in this thing, they get this package. Now, this time it is different. Still, their civilization has the same things. People, same characteristics, a class of people that is well enough, you don't have to till the fields, they can sit and think. But it's different. They have some competition between themselves and within their different localities. Each has those classes of people there, and then in fightings they had to fight each other, the supremacy, whether it was economics, whether it was and for who knows what else, but it was different. Then he came to a realization that the only ideas are not important. It is the conclusions that you can prove from your ideas that are important. And from that, you got the first scientists. That is where the natural philosophers, because this whole thing was always being carried as philosophy. That is where you get the natural philosophers, who are the first scientists. And that is the Enlightenment and that's the revolution, all that. When you ask normal people, ordinary bodies, what they think of scientists, they think for people like lab coats, equipment, and whatnot. But all those things are just consequences of this whole process of figuring things out. So math, science, biology, chemistry, and whatnot. Those are all just bodies of knowledge built up by this process. And the question next was like, why now? So after I understood what science was, I got what data is just recorded information. So data science is like making sense of recorded information in a reasonable way. So for me, that was like my understanding of data science, because at that point, I wasn't really invested in so much in definition, because definitions, you can drag out definitions without understanding what's going on. Yeah. So, like, why now? And to do that, because I was like, data has been around for a long time. Obviously, science has been around. Like, why now? Why 2013, 14, when I was like looking at this question? So, I went to, I don't know if you guys have heard of Google N browse. N browse. So Google has this documentation system, library system whereby they catalog books, they scan them, they get the text, and then they partition the texts by so I don't know how it is, but they have the index. It's the index so many books, and then they pick out, then they get statistics of the texts, of short bits of text in there. Yeah, so that is what Google Index is. So I was like, okay, why not? So I was like, okay, let me search for the term data science or data scientists or science teachers, something like that, in this end graph data, because it goes all the way from like 100. So you're getting all books that are not, that they can get, that are not copyrighted, and they will can search and do this. So I do that, search going on data science, and that is the graph, the frequency, what it looks like. So you can see that the data goes all the way from 1800s, and after 2011, you get, like, after 2000, you get an explosion. And it turns out that that is where I was confused. So when I drove 2011, when I started, that is it. And because this wide scale is, because it's exponential, it doesn't show you that when I was here, you could already see that you could already get the sense of like this thing is like this thing is taking over. And if I just like narrow down between 1960 and 2000, 2000, about 2011, that is what the data looks like. Now, I add a smoothing line. That is it. Now, this smoothing line is interesting for a couple of reasons. If you have been looking at the history of AI and whatnot, you would recognize some patterns here that before you had only seen in non-quantitative like form. Like I will show you what I mean. Because when I saw this, I was like, oh my God, I think I'm the first person in the world to get this thing. And this is what it is. You see this? I will explain it. Now, starting in the 1960s, when the computers, when the electronic computers and the personal computer revolution started, it started people interested in AI. Like there was this hype and bust cycles. Now, when they were very optimistic about the possibility of AI, it was they were writing about they got a lot of funding to do AI research. And when there were, when that research didn't pan out, you had the bust, So these are AI meters. So the troughs here, you have an AI meter and an AI meter. So it starts off like, oh, they're very optimistic. Then they get the trough, like, doesn't deliver results. Then there's a bust. And then they become optimistic again. It doesn't get results, and then there's a bust. And so this graph, this type of graph is available in different tools, but all of them, no, all of them, all of these were from people who lived through the times and saying like, okay, this is how it felt like, that. And when I did my Google, when I grabbed that Google and graphs thing, I got those patterns, but for data science. So I know it has some features that don't look quite right. And I'll get to them. So those are our AI winners. When the projected, utility of AI did not turn out. Those are correspond almost exactly to those analytical things that people that went through the process did know how it goes. But then I saw these two here, these two things here, and I said, oh, what is that?
Very well, 1999,
Because so you have so you have the winters that those features. But what is this? Because this graph, that is what makes this graph different from the others. And this is interesting. 2000 is the dot-com crash. And the debts match up exactly. And then after that is the stock market crash of 2008. And all of those I picked up in the data. So whenever people were writing about data and science, real science in the literature, although the term had not become common, when there was the promise that computerized data will lead to something. And when that promise dipped, they wrote less about it. The other times that they wrote less about it was when the economy was doing poor. So that is what this result. That is what I got from this result. But this graph. Yes. It is possible because this is like, okay, what is the frequency? Because that is mapping frequency. So it is not saying that they really wrote this, but like frequency according to like the other things in the in their index. So it is, yes, most likely it's saying the same moment, or maybe it went up a little, but not too much, but other things like, okay, not take away that. Economists were like, writing them care about that. That's the market and things like that. So we get that. But let's first get to this. When I was reading that PhD thesis, a layered grammar of graphics, I saw this quote here. And saying that, and there was this excerpt with R, we also gain a wide range of prepackaged statistics useful for graphics, lowest smoothing, quartile regression, density estimation, whatnot. And my eyes were caught by the lowest regression. Okay, I know what a quantile is. I told you a quarter, like a quarter of something, or like a quarter, half, like 75%, and then there was a quantiles, your regressions between this as well. Yes, the expressions, yes, you have like your data. What is this lowest movement? And this was the time I was looking at this data. I looked about lowest smoothing. I applied it to those points, and this is the curve that I put. So I was like, this lowest thing is like, it can pick out, let me go back to the points. It it can pick out like that. So that is the original, then so many lowest, and it can pick out that is like because it is Python. At that point, I was already working on like my Plotnine, and when all you are getting better in Python, I was like, it's in R, but also in R, when you're using lowest, I also want lowest in Python. So I started working on it. That's what it's about. So when I started working, sorry, I don't know lowest in Python. And okay, actually I found it. You guys know SciPy, the library? Yes. Now, back in the day, SciPy has different submodules. And back in the day, it had a submodule called the sandbox. The sandbox is where they would put new algorithms that were that they were developing, that were untested, and they were very bad. And that was where the lowest implementation was. When I looked at it, it turns out that that lowest implementation was almost the same kind of implementation. This is the same basis of code as in the R programming language. And it comes from the inventor of lowest who had written it for the paper that he had published, introducing lowest to the world in 1987, 88, and 90, and then the final thing, like 91. It is written in C, Fortran 77, and to get it working in Python, they have to use like an intermediate between Python and C called Python, and because it involves linear algebra, you have to do some like Fortran libraries called last and what also like it is very like hard to package up, fix all the bugs, and make it stable. So that is why it was about SciPy repository, sandbox. And the last work that had been done in it was in 2010. So at that point, I was hanging around this forum, so I asked, like, okay, is it okay for me to like resurrect this code? No, I was like, go. Yeah, it's okay. Like, you don't want to go, you take that. Yeah. So I started working on it. I had a small computer. I had to pull out all of I had to focus on only that bit. I didn't want all the rest of stuff like this. So I stripped it down. So I worked on it, stabilized it, all the memory crashes, you didn't network, etc. You like very like all the 77 is all the yes, like your memory things, and 2 years later, phew, add something that works. But at that point, I wasn't able to go through building a full curriculum SciPy repository because although it works, I wasn't sure of how stable it was. And if I incorporated it back in SciPy, my computer would not allow me to develop and refine it while it was still part of that like huge media. So I was like, you know what? Now that I am going to create, I'm in the process, and I believe I'm going to create my Plotnine library. It won't be a part of the version note. I'm already, I've already created libraries. I'll turn this those implementation into a library with my own. So at the time, libraries that developed, there was this tradition of libraries that that were part of like the SciPy system that had the same kind of structure or all cycles. Now, for example, scikit-learn takes its own cycles for machine learning. So there are others. So I called mine scikit MISC. MISC for miscellaneous. And miscellaneous because I thought I expect like, okay, now there's this lowest thing in there. I will put other things that I want in there. For example, like testing, estimation things like, sorry about that. All those things are put in there. But the pain I have gone through working that package. Plotnine, C, Python, and whatnot. And I still think that means that I didn't want to put anything in there at the level that stuff is. But I don't want to because it is a huge package. And the pain is similar to is that like people package like sci-fi for me to get it and install it, I go through a lot. Now for me, I was one person, but I was like going through because very few libraries in the Python ecosystem have those things. C, Python, Fortran, Python. And then the part plus the part thing for me how to once you have those packaging there so that users can install this paint because that package is almost standard, every new release, what more things like it breaks. So I was like, oh, I am not going to do anything with that. But anyways, that came out and when Plotnine was ready, the other graphs we saw, so this is Plotnine and it uses right here lowest flow cycles. But the reason I went through all that because I was brilliant by what the lowest are going to. So lowest stands for locally estimated startup point smoothing. So what it does is okay, you want to smooth out this you have so many points, you want to get a target out of it. You just look at let's have a small neighborhood points. Do a kind of this called regression, get to the next step, do a smaller regression, and then you put things up. It's a non-parametric method, which basically means we're not bringing in statistical assumptions, just like you just define a span and work. But yeah, so Python. So I had Plotnine, I had lowest CFA. Now this is the last part, reflections. Now Plotnine has succeeded beyond my imagination. Right now it gets about 3 million downloads a month across all platforms available. So cloud computing platforms and whatnot. It has a book written about it. Although they didn't send me an electronic copy, it has another book where it was where it makes up like half of the material written in Chinese. That was like 2021. They sent me an email to write a forward, and they sent me a digital copy to move to me. So if you look, so like they're like, oh, yes, you just you can see the code, you can see the graph if you just and write your review. So that
So they want your place.
then I got it. But for a book in Chinese, I don't know if they translated, but anyways, I got it. Yeah. So I got here. So I got the and what is it beyond my wildest imagination? Beyond my imagination, like I mean, it is taught in data science courses in industries around the world. And of course, I get emails like, okay, yes, we'll be using your library, but how do you pronounce your name? Then you spell out, okay, Kibirige. Yeah, it's coming. It has I've gotten 3 awards from the Google's open source awards. I can give out because Google has this culture, developed this practice of they use a lot of open source software. And also internally, they used to recognize the employees that went above the information. Oh, it's go there for the you know what we expected from an employee based on the information. And then they realized that okay, they use a lot of open source software, and some open source software does a lot for them. And they're like, okay, let's recognize some of the people who get this software. And that is where they came up with their open source gear bonus. It's an international thing. They give it out 4 times a year, unfortunately 3 times. And I think 2 of those times that when they African. For Plotnine, because it turns out that people at DeepMind and they tell you who nominated you. Wait. And they give you some money. $250. But then they publish your blog post and whatnot. So you get the credit. But then also beyond my imagination, I'll get back later. Plotnine value 0.15 shipped last week. And this one has something a feature that when I released the first 0.01, I thought I would never be able to do, because let me see. Okay, I'll skip it and just explain it. So if you look at this visualization, it is 3 different plots together. This is called plot composition. So you develop 3 plots, very different. I want to differentiate it from, see these 2 here? These are not different plots, they're just same panels of the same plot. So you have the same graphics in both of them. So this is one plot. These are different. And this is, when it comes to creating visualization libraries, this is the hardest thing. Creating a layout that allows you to put different graphics together, because you have to align. You have to say, okay, this thing has been created here, this thing has been created. When you put them together, they have to look good. So you have to align. You have to make sure that your edges align. You have to make sure that things don't texts don't overlap. You have to take care of so many different things. And I will let me look for the issue here. Okay. There. So here they call it household statistics. So this came out like 5 months after I put out the list. So they were asking for plot composition here. And my response, as in, you cannot go subplots. It will be implemented with Matplotlib as a better layout manager. At the moment, it will be hard to implement. I said hard, but I really expect I said impossible. And I closed this issue 4 days ago, because I shipped this composition last year. So between 2017 and today, and up to the shipped the first value, it's still going to go through an evolution. I had this thing on my mind. I wanted it because before even this person submitted this issue, I knew like, this thing is important. People want it. I wanted it, but implementing it was it is very hard. So the people who use it will never know. And I will show you what it does. You see, you create different plots and you combine them with like an algebra. I have plot, I have plot 1, 2, 3. I say 1, 2, 3 besides each other and 4 below it. And it just does that. And it takes care of aligning these things, aligning the text, aligning. So 8 years in the making, or 8 years in my mind. Obviously working on other things, but always battling me. And that is just like one. So when you ask me whether it's I still maintain it, yes, I still do. And also, that loss has had surprises for me. In 2020, I got a call in October from someone who was developing, not developing, they were working on clinical tests for COVID vaccine. And when you're doing clinical tests and preparing for how you're going to analyze data, usually the good practice is you prepare all the analysis you will do before you get the data, so that you're not picking and choosing the analysis to pick the data. And when they were doing that, they were like, okay, they were using psychiatrics, they're using those. And because they had simulated data, they had some mathematical principles. Below it, there's some algebra. So they were like, what is wrong here? So they contacted me also. They contacted me, organized a Zoom meeting, and they are looking at. So at the time, I didn't know whether I was looking at real data, the COVID clinical. But I remember this is October, before September, mid-September, before people knew that people were working on the vaccine. Here I am. I created this campaign, and people are using it. And then I find out which vaccines they're going to be using. Later on, I find out which vaccine they were using it for. And obviously, vaccines came, I don't get that. Because I wasn't disturbed by people with conspiracy theories and all that, because for some reason, like, out of that process had opened up to me. Yeah, so like, that's surprise. And although many people know about it, for me, like, that is like the biggest good.
Always imagine you can imagine how many people want to be. People are much more working with that idea as a solution. We usually know how to.
So I don't know whether when the data came out, they went ahead and see, but I know at least when they were planning, they considered it.
Oh, it's really cool.
Yeah,
they don't want to be from, that's why.
So the other one question is like, why now for us? Like, why are you guys here? Like, what is this whole like data science thing? Like, why now? Like for us, like it's the same thing, isn't it? We are here. We all comfortable now. You know, we don't have to do bad work. Our
We have computer.
yes, we have yes, we have, you know, that we have the freedom to think about to do these technical things. That is like the same process that started like, 2,600 years ago. Like we have like, jump into the bad, like that bad water. But we have jumped into it in and skipped a step. And this step has consequences. That step is we've really skipped. We're doing data science, but as a society, and most of the rest of Africa, we haven't done science. So those places, they did that. They do the philosophy, they do all those societies, then they graduate, they do large science, and then they graduate, obviously the data science and all. For us, we're like, okay, computers, data, they are cheaper than doing the science, so we're just doing that. Data science. Yeah. I know there are few people doing that. I know. I'm saying, I'm speaking about generally that we're speaking for science. There are few people doing, science, but it is, we cannot say that we are a society that does science. Yes, we go to number. Yes, we do. You see,
we can't compare ourselves like we used to be pretty high with the rural academy of science.
Yes.
Yes, we come up with a theory of math.
So, yeah, and that has consequences. One of the consequences became like real to me in 2020, and I will explain it to you. When COVID hit, there was before we got obsessed. Before we had a killer of COVID they call it. So people are going into, people are being admitted. Remember, the president would come and say, okay, after so many weeks now, our account stands at 40 whatever. We have all of them are treated, and none of them have died. And it works. Then the minister of health would also give press conference and say, oh, yes, we are managing this thing. We're putting it and it said, yes, it looks like, but where did they get that idea that chloroquine works? The first people to use chloroquine when COVID came out was a small hospital, it was Italy. They tried it on 14, no, about 20 people. And the results were like, hey, it looks like it has a marginal benefit. But it wasn't conclusive because it was a small number. Within a month, it's no longer actually. It's no longer, if you look at the existing therapy, so people know. So within a month, another hospital that was being provided for the patients in Italy got to try out chloroquine on a larger number. And they actually found that, although not statistically significant, but it's not even performed worse. So 2 clinical studies. The first one was the height. So the people we here jumped onto that bandwagon for COVID, but because we are a society that knows how to administer, because those societies don't know how to administer chloroquine. It is a foreign thing. But because we have malaria, we know how to administer it. We jump into it and like, oh, so this again. And we are like, oh, it works because people are not dying. But when the Delta wave hit, that random like probability thing just went away. So we have to face that reality as a political. But you didn't have to say that. You didn't have to go through it because by the end of April, before we even started giving COVID, it was out there that this thing is past the clinical studies. But and that is where we discovered doctors actually are not scientists. They are practitioners. You see, and that is an existential threat for people like us who overthink things.
What you're saying is, let's say, you don't know if you can use the blood brain of these who have infections. So when you go to see a physician, you have to tell them the first question they have. Yeah, you don't know, you can't necessarily really know it's malaria. Because you see, you'll be portraying signs of malaria. But before you know it's an infection. So for them, they'll tell you, you can't draw any conclusion except putting you in the treatment. without actually knowing the code. You know, for us, what we need is just follow the rate and we necessarily what is it really working on the network. Yeah, because at least with that. So, there was a saving grace. Some months later, doctor scientists did actually carry out clinical studies on about 115 patients, and they debunked it. Say that, oh, this thing does not work finally, at least as well. I know these are different doctors. There is now this one of them is like this year master. Yeah. So the paper came out in 2021, like December or something. So when I saw that, I was like, okay, at least definitely these people must have felt that dread where the practitioners are not just going out there and saying, that is a consequence must be recognized for skipping that down. Second consequence happened last year. After the census results came out, we had the headlines where we published. There is a material.
No. Populations for different regions going down, but clearly wrong. Yeah. Now, most people looked at UPOS as being incompetent. The Passover, how can how can you say that our population has gone down? It's not giving us
You're joking.
You're joking. And most people looked at you, boss, as being incompetent for that mistake. But that is a consequence of skipping understanding. Because here is how that mistake comes about. And I feel sorry for you folks because I will not call them incompetent for that. Because I understand that I'll tell you why I'm in position to say that. I understand how that mistake comes about. And it comes about this. They did the analysis, they did the tallies, they summed up, they got their numbers. That stuff was right. And then when it got to publishing, they started copying here and there and made a mistake. What they published was not reproducible. The process between the analysis and the publishing was not reproducible. That is where, and you could see that mistake coming. Because if you ever play around, because at some point I used to download a report data look, and we used to have, I haven't done it in a while, so the Excel sheets. When you look at it here, so at an Excel sheet, and you see the numbers there, and one number, all numbers are say left aligned or center aligned, and one is left aligned. That means someone was playing around on that sheet. And that is definitely not reproducible. So they could have made any other mistake. But now you see this one, it's just an alignment thing. So yeah. So, and the reason I was able to say like, okay, and I feel sorry for you bosses because I know this thing of reproducibility has been breaking the Western science world for the last 15 years, 15 years. Because when I started to develop a Plotnine, the people I joined, the first one, getting to develop people's package, I returned and nobody in Plotnine had the income. Very, very influential person in our community, and the company belonged to join RStudio. They started creating packages for reproducible research reporting. So that is where those meet R, it's in R code we mark down, and that is where we get R markdown. And because I was involved, I was looking at what I was involved in that community, I had, for all those years, I had an appreciation, understand the problem of non-reproducible research for that whole. So when you both made that mistake, I could see it. Not because I was smart or anything like that, because powerful, loosely being in that community. But that community, but I was not just loosely being in that community, because in 2022, that person was called Plotnine, called me up, and right now I have a job with him where he's like, the essentially gave me a job where I did the work of Plotnine and other data science packages. Still, when I was showing you that some people came to my say fence or something, one guy told me that now I work with him. He also joined that same company, and he's like, he's my colleague. And still, within that same company, still we have the creators, Panda, is a key. Or Chrome, like open source, getting into the community, and growing within the community, persisting, because this is not overnight. So I used to do this before I had a coding job. It's my first job I have. This is my first coding job.
We're talking about who you really got to understand the language itself,
Yeah.
You persisted all that time and level to answer.
Yeah. So right here, so right now the fact that I go to say a company Meetup, where because it's everyone is remote, the company is like 300 something, but once a year, you all go no Meetup and you talk to the other people, partners, obviously you created Arrow, I got all this, like, yeah, it's not really you have I'm like, how did I get kind of thing? And then you get to those conferences and you meet people like, oh, you're here, they're pretty, yeah, yes, we love it. And how do I get some So that is the power of community. Most people think when we think of community, we think like getting together physically, but community is an idea. And once you tap into that idea, you associate the community gives you community shapes your aspirations and what you think you can do. The reason why I spent 2 years not working on community is because anyone in Uganda who created a package, they create this package a lot. I had self-doubt, I had all those things. And even I still have self-doubt now. Now after bashing, I've done something because we all have self-doubt, and self-doubt is not bad. After you've done something that you never thought you could do, you learn something that the self-doubt that you have does not account for the growth that you will undergo when you are pursuing what. So if I want, if I want to say I am at the bottom here and I want to get up to here, and this will look big, self-doubt. But once you start going on the journey of going up there, those are stairs. So you don't recognize those stairs, and you don't recognize the mountain. But when you start doing that, like, yes, sir, okay, everything. And within those layers, there are small layers. And unless you do that, you don't put your mind into the position it needs to be to think about those small problems. And those are small problems. So what seems big, once you accomplish it, like 3 weeks, so many things, I found that so many hard things, or you find a pathway, so many hard things that I have big blockers in like 3 weeks. So it has a very focus on it. And this is not just like always been, it's just like, oh, okay, this thing. So you go to bed, like you do other things, but that thing is still in your head. And then afterwards, you read something else, somewhere it sparks, and then something you never thought you come, it's done, and now you move on from that, just come back in your toolbox, and it gives you the confidence. Yeah. So with that, thank you very much. Yes. Any questions?
Because of time, I think we are going to have 3 questions for the first resident.
Who wants to be good at English? I have something for myself. I think it's sorry for the list. How many of you know? Good. Member of Plotnine, the same. One of my questions for you. What can you things that I things you think I don't have. What one thing I learned from the beginning of this presentation, at school level, at the beginning, then later, some lawyers and so on. Whenever you get something hard, how many of you want to see that as an opportunity? No problem. That's not a place. Number two, how many of you have come across the word RIT? GRIT, RIT. Do you see it anywhere in this document? Or this document? You know this thing of you can squeeze me and be on the water, but I'm not a fish. One day I will come out. Patience, resilience. Another line of reflection is, did you have to see where he is now when he started? No, never.
But let me tell you something that Plotnine now, when Microsoft Excel added Python, Plotnine is one of the libraries included in Excel in Python in a single business.
Good.
I would never have this because it's all necessary. So it's like,
So my point here is, can we learn to do certain things at the back end, regardless of where we're going to them? Think like how for social media. Go to one experiment. Just do a lot of mapping on social media. You are able to see too many things and not of the free. It has some addictive, dangerous effects. It takes away concentration. So if you want to be a scientist, I think you're going to make some choices on how you use your time more. Okay. That was what was doing of the I want to see Plotnine or see different things with him and with Mr.
You went to a country where they have a something like refreshing, and it's a very good different, but very good on the table. You both have the same.
So it's not about you going back to make another Plotnine. Plotnine elsewhere. In your have things that are fitted. Then in the story of libraries, is something I also wanted called the interoperability. You're on Python, you've seen something in Java, you've seen something in C, you've seen something in somewhere. How does it work for me now? How are the translations working? Can it be translated, or I need to really track some coin somewhere? Then of course, finally, I decided that we have a tool to use. We really struggle with some of those things, especially when you want neatness and compactness. So I don't know when this will be easier for us to incorporate as part of LaTeX. Because most of the scientists are writing things and visualizing want this to be in LaTeX and so on. Maybe someone is going to pocket from here and see how it can be incorporated as part of LaTeX. But I'm excited that as part of this, I am beginning my journey of enjoying data science, machine learning, and so on. Some of us who started programming using Pascal, you can see the problem we have. So, thank you so much, Hassan. Those are my observations.
Thank you, Mr. Swami.
Like we going down and personally answer them that was that group personally. So we are only going to have three because our time is participant. I think it was the second, then with the third, and the rest is right there on the which we're given, and also feedback.
Also, mine is not a question, but I think an addition to what it's sorry about faith and what Hassan was doing. I come from electrical computer engineering and electoral. I'm interested in discussion and of course engage young men. So this is a very important topic, the past year. And they're going to so I realize we are trying to need to learn and know how to apply. So a lot of the things we do, we just take on higher. And now when we visualize and we put it out properly, this interoperability. Because now we are collecting data, data has become so important. And I want to see that where it would end up when now we go into the social media boom and smartphone, where that comes because we saw 2011 where we had the session and everything, but now with the social media, because now we have a lot of data things we never used to see long ago. Now we see a lot of data around us, and now this idea of being on social media and you get taken away. When you evaluate yourself at the end of the day, you realize you have nothing. You haven't analyzed anything, and now you also have to like what it sees depends on what you do. Like, because each of us here, we have already profiled. Profile everybody based on data. But what is the most important is data. So how you customize all these get data from different sources? Because for me, coming from the telecom world, I want to see in the morning, I see people moving. How to even the shopping, because now people are even monitoring how we are shopping, what. But here in Uganda, we don't do electronic online coding, but it's coming. And how you can capture it and how can you harness all these many opportunities around us to really do that. Otherwise, I would really want to invite you to come to the bank and engineering. We just start with my students. Because this is a very nice interaction so that people get moving and they use their free time wisely. Thank you.
Thank you.
Probably the bonus for lady.
See, when I go back to my city, yeah, I think I'm taking this down. So where I'm going to get it down, for going and Plotnine, that indeed the job on my mind now open. I've really seen, I've learned a lot. If I'm right here now, what I've been learning, I think I can begin and tell you what I've been learning here. So, really thank you for the great work. Especially the lot of questions there, and I've realized, me personally, I'm not so patient, but I've learned to be patient in stuff. My question is a short one. Just wanted to ask, like, as you wrote in Plotnine, did you integrate some other Python packages or
Yes, it lies Plotnine. First of all, it relies on Matplotlib, but it doesn't use Matplotlib the way most people use Matplotlib. Matplotlib is just there to draw a canvas. It's just there as a canvas. So it has its own processing pipeline. Matplotlib was not meant to be used that way. So it is a huge pain for me, for Plotnine to use Matplotlib that way. It is, that's the best thing it can use, but it's a huge pain. It wasn't meant to be used that way. It uses there's a method called stats models for some of the things. It uses obviously based on SciPy, some of them. And then for the scaling, I had to develop, there's another scaling package that I developed called Mizan that provides the scaling functionality. Obviously, when you develop these things, you name them. So everybody who look at the name Mizan, they don't know it's like Mizan from so your use of Mizan is part of the package that you provide the scaling. It's like the rock horse behind all the protein. So yes, those are the main packages that we came for.
that is
Yeah, on the issue of you said you are motivated.
yeah.
Look at it this way. One of the things that we all struggle with is our education system. By the time you guys are here at university, when you guys are by the time you get to university, there is only one thing you can say you're good at. That is passing exams. The curiosity has died because that is not examined. But if all kids are curious, by the time these professors are even are still discovering themselves to for that. This work, what's it, requires curiosity and interest. And how you learn to nurture that determines, because it is hard, no question about it. But if you're not curious and if you're not interested in it, if you're only doing it because if I check this off, it will look good on my resume and or CV and I'll get a job. It will not, because you'll have to go through years. Maybe there are some smart people who can look at it and say, oh, they can do it within, like, they can have the courage and the focus to do it within 3 months. Such that, hey, but if you need to, but to get good over the long term, you need to be interested in something. and learning how to merge your interests with this other intellectual stuff is the most important bit here. As in, if you, what are your interests, for example? What are the things that you're interested in life? No, mention this.
Like in this.
No, forget this, mention any other thing.
Yeah. So, to have like, okay, like every youth, of course, dreams of having a good future, like having a good house.
No, I'm not saying
Football, right?
yes, okay, football, yes,
Riding,
yes, sir.
music,
Yes, yes.
yeah.
Now, from those, you're interested, you say football, you say riding, you say music.
Every first session.
Like, you know, if you're interested in the intellectual stuff, say you're interested in the data science. There's a lot you can do with football analytics. A lot. You can say like, okay, how do I start analyzing? And then you will discover that you will get very, very good at the different metrics, where how they apply, how they go out of fashion, how we do it. Someone who does this Plotnine, all the this Plotnine to do their football analytics. Maybe at some point I stopped, I still for the paper. Another person uses it to do Facebook. Facebook. So if you're interested in music, I'm not saying you okay, you bring your own self to your interest. That is it. It doesn't matter what. If you're interested in music, what types of music can you get the music? Get the raw form that is such that it is an amplitude, you decompose it into the frequencies and whatnot to find the different similarities and whatnot. And so you will engage intellectually with music, and you will get to levels that you will never have imagined, because each and every one of those things that you won't say you need motivation. As in what motivation? You'll say like, oh, chameleon song and this person's song, when you actually decompose their Fourier transforms, they have this similarity. You like do so many things that are like off the beaten track to do, and guess what? You'll be improving technically. Because all of those are all of those require you to invest, right? But you also do it with joy. Okay. So you can go like think about, I'm not kidding when I'm saying that once you discover that, once you discover the power of that, that should give you goosebumps to realize how powerful that is. How powerful being curious and being interested and much interested and to above your raise your curiosity. That gets over what you're talking about, not being motivated. Let me show you an example. Share.
So where I work, we have a policy, part of policy for maintaining 5% of the spam. So I was used to like using what first city that I wanted. So I realized every days I have to come up with a new password. And every time you told me I don't want this password, I want this password. There's something like my generator. I realized a little bit of Python. Python, I write to Python, a script, you know, for myself. And Android is actually now. It has Python in like in there. I can access Python in there. We don't anything else. So anyway, listen to speak. Every time I want a password, I'll just run this. Okay, I'm not sure.
Here it is. with my company, they created a visualization contest. For people to the 2024 Plotnine contest. If you are on the PyData group, I invited you guys to take part nationally.
What's another one?
Now, as it was closing down, we're kind of like not so many, about a week, not so many had come in. Okay, please tell people that we need to spark some imagination. And I wrote this blog post. I had always wanted to thought about doing visualization apps.
Visual art.
Yes, visualization, generative visualization, you generate the art, but that one, not whatever. And then, okay, I'm like, in calling for people to what to think about when they're submitting for the contest, how about an art? Someone, I got also inspiration from someone. You have this, look at this, there's code here, randomly generated like triangular things. Now, what can you do with these triangular things? Now, I thought like, okay, what if I give them colors of landscapes? But you have to generate these triangular things in a very specific way such that you can color them. And these triangles are the same, but what changes is the color I add. And I give it a name because I'm now an artist writing the code. I give it a name. I say, oh, spiky desert dunes. Yeah. And with that, I only change the colors. Same triangles, I change the colors and I call it, oh, a spiky volcano. Yeah. Same thing, I change the colors, same. Oh, I say a morning in a spiky forest. Same thing, but all of these use the same color palette. But I wanted something like a different color palette because all these color palettes are like, I wanted something different. So I was like, what landscape has to give me a different color palette? I was like, oh, a spiky sunset at the beach where you see the sun, the water, and the sunset. And all of those are putting different colors into the same frame. But it took, generating these random things and such that they can take those colors. Where would the motivation come from someone to do something as serious as that? And this is my first visualization art. All the time, and I have a colleague who does visualization art, and that's all right.
No, you always understand. When you work for things and know about what you do is what you see at the back. But most of the things of the forms are like that. You see, we are kind of the things are the design artists. And you can't do what they're working for.
Don't ignore your other interests, however stupid they may be, however silly they may be, but that is the secret to all these things, because silly and interesting things are harder than the structured and straightforward. But we can give them time for a longer. Yes. Past today's workshops. The question. So if I get, can I come again? No. It's all the days.
I don't have one. Thankfully now, I've been a day that is required. And I think what you have next, I'll come to, and I look at the word, I said, yeah, we have to move. Just because we know we are being difficult stuff. And just make that up. We have to put and for those who know the question and think about it,
I do believe we have not done that speaker enough. I, for one, am speechless. I can't say much. This time, and I believe we need to release the Posit that has been shared. We're feeling the same words. As they are speechless. They have said us for what you can us. And I believe if you redefine the definition of committee and from here, what yes, that's my answer. Okay, thank you very much.